The director wanted a cityscape that was pretty close to real life, yet also captured the pre-dawn lighting scenario that we had from the video shoot. He went through a few photos of cityscape backdrops from reality and selected a good working example for the shot we wanted to create. When we overlaid the live action footage over this photo, the director felt that the two elements matched pretty well. Your team is to use this photo as a guide to create a realistic future cityscape. The objective here is to create and render the buildings into a single large image that can wrap around the 3D scene that we created with our match moved camera. This is called a cyc, or cyclorama. I need you to choose from two different methods of creating and composing your cityscape cyclorama. Of course, these buildings don't exist in reality. The good news is that the buildings have already been modeled and textured for you in 3D software. The bad news is that things are not as straightforward as they seem. It would make sense to simply place all the 3D buildings into the scene at once, arrange spotlights and turn on global illumination for a quick render. The problem is that for the number of buildings we're using in the scene, there aren't enough resources in the computer to start such a render. Any attempt at rendering crashes the computer. To allow you to work with your buildings and still have complex shadows and bounced light, you first need to pre-render those characteristics and manipulate them separately. There are two possible methods that I'd like you to consider. The first method is a 3D method that can keep all the buildings together in a 3D program. I know, I just told you that there aren't enough resources to accomplish this normally. But what if we pre-rendered the global illumination and shadows for each building and simply applied those renders as textures on each building? This is possible in a technique called baking. Instead of making the computer simulate the bounced light for the entire city at once, it only has to be done for each building individually, one at a time, using the same HDRI lighting system that we used for the railings. Once baking for each building is complete, we are then free to place the buildings in 3D space as we see fit. All the textures will still bog down the computer a little, but not nearly enough to crash it. From here, a single render can be performed and then combined with the sky element in Photoshop. The finished city cyc can then be wrapped around the scene with the match moved camera and rendered as our background pass. A second possible technique is called 2.5D. Each building is rendered separately and projected onto cards, which are placed into a 2D editor like After Effects or Nuke. The cards are positioned in 3D space this way and rendered as the final city cyc. To use images of buildings instead of 3D models, a variety of angles must be captured as still images. After modeling, a single building would be placed in front of a 3D camera. The building would be animated, rotating 360 degrees in place. The camera can then capture 6 images of the building from 6 different angles. Each image is saved and mapped onto the 2D cards in the 2D program, and placed as they should. Each building would be rotated, captured, and mapped in the same way. Advantages of the 2.5D method is the use of computational resources and in the degree of control available. It's much easier to control the placement of buildings because the buildings are flat planes and require less resources to display and manipulate. 2D shadows can be more easily created with flat planes than using 3D shadows. Disadvantages of 2.5D is in realism and required labor. While 2.5D adds control, the 3D method allows the camera to capture the proper parallax that should be present when the buildings are all present together. The perspective of some of the buildings seems wrong because of those buildings have been scaled in 2D. In compositing software, realism is often enhanced with the use of a depth pass. A depth pass is a simple grayscale image of a 3D scene. The different values of gray can tell a compositing program how far away from the 3D camera that an object is. The more gray the value, the further away it is. This kind of pass is very useful for adding atmospheric effects, haze or blurriness, that inform viewers about the depth of a scene. In the 3D method, depth maps are easily created. With the 2.5D method, depth maps are not possible. Depth cues must be guessed at and hand-created, requiring more labor. Why don't you compare both examples and explore the quality of each shot? Click each of the renders to open them in a browser and zoom in to reveal the details. Think about how noticeable any artifacts may be. Then compare the cost of each method and see if you can figure out which is right for our budget. Good luck!